Hello, I'm an old guy and I do maths, and today we're looking at a couple of Z-score problems, or a couple of problems associated with Z-scores, so maybe that's a better way of putting it. So the first problem is that we're given the following information. For a normal distribution, a piece of data has a Z-score of 1.2. The mean of this distribution is 174.5 and the standard deviation is 4.75. Now, the background to this problem is that it was a worded problem that a student of mine was given, and the wording was to the effect that in a group of people the mean height was 174.5 centimeters with a standard deviation of 4.75. One person had a height whose Z-score was 1.2, and we were tasked with finding the height of this person, finding X, the piece of data. Now, it's reasonably easy to solve this. So let's go ahead and look at the solution and look at a couple of, the algebraic way of finding it, which means that we can do it on an ordinary calculator, or if you've got a very smart calculator, you can just ask your calculator to solve an equation. Now, here's the information put into the formula for a Z-score. And just to refresh your memory, I'll just grab my pad and I'll write out a couple of things here. So Z is equal to, so if we look here, we've got the piece of data we're interested in, the mean and the standard deviation. So it is equal to X minus the mean over the standard deviation. That's the formula that we're looking at. And what we've done here is we've entered the information that we have. The Z-score was 1.2, the mean was 174.5, and the standard deviation was 4.75. Now, the answer is that the person is 180.2 centimeters tall. Now, how do we get that? Well, the first way is that we just pop that into a fairly smart calculator and ask it to solve for X. What's the algebra involved here? Well, just give me one moment and I will do that for you. So we have 1.2 is equal to X minus 174.5 all over 4.75. That's the information that we have. Now, I'll just do this on paper. So the first thing we're going to do is we're going to move this 4.75. And that is equal to X minus 174.5. We want to get X on its own, so 1.2 times 4.75 plus 174.5 is equal to X. Pop that into a calculator and you will get 180.2. Okay, so that's the way in which you do this if you've got a fairly simple calculator. You could even do that by hand, but I think we've left that behind some time ago. Okay, looking further into this problem, I thought I might illustrate it for you. So the problem that we see illustrated here is exactly the problem that I outlined. So the mean height of people in this group was 174.5, and the standard deviation, one standard deviation added 4.75 centimeters to that. Now our person's Z-score was 1.2, and that places it between the first and second standard deviation approximately here. So in a graphical sense, you can see how a z-score works here. It's the distance of a piece of data from the mean, and this is 1.2 standard deviations. Anyway, that's just a little illustration of what we're dealing with. Now, a second problem based on the same information is as follows. So we know the mean, we know the standard deviation. If a person's z-score is 1, what is that person's height? Well, the short answer is that it is that plus that. And I should illustrate this, I think. So just very quickly draw my poor artist's impression of a normal distribution. What we've got is we've got the mean here, which is 174.5, and our first standard deviation is here, and that adds 4.75 centimeters to our person's height. So if they have a z-score of 1, that means that they are from here to here, which is our data point, if you will, it is 1 standard deviation. So in order to find their height, we just have to add this badly written number, which you see reproduced more visibly up here, and this number here. And that gives us our answer. It's actually very, very simple. But in order to do this, you have to have a good understanding of what a z-score is. And a z-score is simply about the distance from the mean to your data point. And if that is a whole number, 1 or 2 or 3 or 4 or beyond, because it is possible to have more than 4 standard deviations, if it is a whole number, that value falls on one of those standard deviations. So it's simply a matter of taking the mean and adding or subtracting accordingly until you get to that standard deviation. The other way of solving this is to put it into the formula and ask your calculator to solve it, or do a little bit of algebra. So the z-score is 1, and that is equal to our value, which we don't know, minus the mean, which we do know, over the standard deviation. So if we sub in those values, we get 1 equals x minus 174.5 all over 4.75. A quick bit of rearranging in algebra. We get 1 times 4.75 plus 174.5 equals x. If you're interested in actually finding out what x is, you can just add those two numbers. It's by the look of it, 179.25. Just doing that in my head, but don't quote me. Anyway, I hope this was helpful. If it was, please like and subscribe, and I will see you in the next video. Thanks very much for watching. See you next time. Bye.